Hi guys, welcome back, and we are going to jump into 2.5, which is solving for a variable. So sometimes in math class we'll have an equation with lots of variables and we need to solve for a specific variable. So if we look at this formula right here, we have d equals r times t. This is a special formula. It's distance equals rate times time. We use this a lot later on in math class, and you'll use it a lot in science class. So sometimes we want to be able to solve for different variables. So right now this is solved for d because d is by itself on the one side of the equals. So if I wanted to solve for r for this one, I would say, okay, what is stopping r from being by itself? Well, t is stopping r from being by itself, and t is being multiplied by r. So to get it to the other side, I need to divide both sides by t. So now I get r equals d, which is distance, divided by time. So this is now solved for r, because r is by itself. Okay. Next, let's solve the same formula for t. So again, we say what is stopping t from being by itself, and that would be r in this case. R is being multiplied by t, so I'm going to divide both sides by r. Sorry, my pen's being a little fussy today. So I'd get t equals d over r. And again, this is solved for t because t is by itself. Now for some of you, you're going to be like, Miss Haas, why are we doing this? This is super helpful when we get into our graphing linear equations. Also, as you get older, you will need to be able to solve for a certain variable. It can just be helpful sometimes, okay? So let's go on to a little more complicated one. So this is the formula to convert from Fahrenheit to Celsius. So if I had Celsius, I could plug in the Celsius degrees and figure out what the Fahrenheit is. So this one is solved for F, obviously, because F is by itself. So we want to solve for C. So the first thing I'm going to be like, okay, what's stopping C from being by itself would be the 9/5 and 32. I always do backwards PEMDAS when I'm solving, so I'm going to go ahead and subtract 32. Now, I can't do F minus 32. There's no numbers, right? I can't combine variables with numbers right now. So I'm literally just going to rewrite F minus 32 equals 9/5 C. Okay. And then here I would say, well, the 9/5 is stopping C from being by itself. Now, a lot of you divide by 9/5. I would highly recommend multiplying by the reciprocal in this case, so 5/9. And notice I put the F minus 32 in parentheses because that whole thing is being multiplied by 5/9. Now, I could distribute the 5/9 in, but it's not going to reduce anything nicely. It's not going to look pretty. So I would just leave it as C equals, because this canceled to be 1, 5/9 times F minus 32. Okay, we can leave it like that for now. If 9 had evenly gone into 32, I would have distributed it just to make it look a little bit prettier, but right now that's as good as it's going to get. So that is solved for C because C is by itself. All right. Go ahead and try this one on your own. So we have the formula m minus n equals 5, and we want to solve for m. So if I solve for m, I'm going to add n to both sides because that's what's stopping m from being by itself. So I get m equals 5 plus n. I could have also written this as n plus 5. Either way would be the same thing because addition is commutative, as we've said before. Okay. What happens if we wanted to solve this one for n? So in this case, I would subtract m from both sides. So I'd get negative n equals 5 minus m. Now n is not by itself yet because I have this negative, so I would divide every piece by -1, because that'll save us some hassle here. So this becomes a positive n. 5 divided by -1 is -5. And negative m divided by -1 would become a positive m. Okay. All right, let's go ahead and try this last one here. This one's a little bit more complicated. So we have x minus 2 over y. I'm going to rewrite it so I have plenty of room, equals z. And I need to solve for y. If what you're solving for is in the denominator, we first need to get it in the numerator. And we're going to do that by multiplying both sides by y. So for some of you, that's going to be hard because you're going to be like, well, Miss Haas, why am I moving the variable that I'm solving for? Sometimes that just has to happen if it's in the denominator. So now I say, what is stopping y from being by itself? That would be z, and z is being multiplied in this case because they're right next to each other as variables. So I'm going to divide both sides by z. So I'm going to get y equals x minus 2 divided by z. And now y is by itself. Have a wonderful day, and we'll talk to you later. Bye.